Good morning, good day, or good evening, everyone. We will wait another minute or two to allow everyone to join, and then we will start with a live stream. See you in a bit. All right. Hello, everyone, and welcome to this next and at the same time last live stream of our Bicep series. In the last live streams, when we covered Bicep, we mainly focused on how Bicep files are actually authored, what techniques are available to author and write Bicep files, how you can modularize your code, etc. And today we will focus on mainly the deployment part. So once you have your code ready, how can you release your code to the Azure platform to finally deploy your service, or of course maintain your service if it's an already existing version living out there and you just want to maintain, maybe extend the service or reconfigure the service. That's the topic of today. Now, before we start, remember the session will be recorded and it will be available maybe a day or two after the presentation. And if you have any question, feel free to use the chat window. We will try to answer all of your questions either during the presentation or at the very end. If we still have some time, we will take your questions then. So feel free to ask whatever you want to ask, not necessarily related to today's topic. So anything Bicep related can be thrown into the Q&A window, and we're happy to help out, or at least to try to help out. All right, before we get started, quick introduction about the speakers. Martin, do you want to go first?
Yeah, that's fine. Welcome everyone to our latest, or at least for now, latest Bicep stream. So my name is Martin, and I work at the payment platform in Norway called Vipps. So I've been working here for a year now, and also been working with Azure for probably many years, you can say now. So apart from that, I'm a Microsoft Azure MVP, and also I like to ski and drive race cars in my spare time.
All right, thank you. Interesting hobby, by the way, driving race cars. That's not so common. Let's say that. All right, so my name is Marcel. I work at SoftwareOne. We're a global company helping customers on their cloud journeys and digital transformation journeys. I operate out of Switzerland, and I'm the team lead for one of the teams here in Switzerland. We focus on everything Azure M365 and security, and of course, infrastructure as code is one of the big topics that we help customers with. All right, now as I mentioned today, it's mainly about releasing code, not about how to author Bicep files. But what is important when you actually have your Bicep files authored or created, you should ensure that they are somehow managed by using source control and versioning. And what does that mean? From the very beginning, when you start authoring your Bicep files, you should ensure that you are able to somehow easily, well, track changes. You can see who did what changes on your Bicep files, because once you release your code into production, this is, I think, a vital element to have these insights. Otherwise, you might handle code or release code to a platform and you will never know, well, has anyone changed something? And might that change maybe break my application that's living out there? So this is not what we want. And so that means we need kind of an application or a software that helps us with source control and versioning. And the most popular one is actually Git. So Git is an open source software that you can use for doing exactly this. You can install Git on your authoring laptop or desktop, and then start tracking your code changes, which means you develop code, you update your code, you check in code, you have commit messages so you can see what changed, and you have this, let's say, audit trail across your code changes available all the time. This gives much transparency. This can be done totally locally, or if you more work in a team, then you might later want to push your repository to a central location, to a central place where other developers can also access your repository. So you can actually share the same repository across multiple devs, and you will have like the commits and the code changes of all the devs in the same repository. Platforms that allow you to do this are, for instance, GitHub, Azure DevOps, and of course, there's also many more out there. Now, one concept I want to mention here is repository branching. So what does that mean? When you start authoring your Bicep files, you normally start creating a new empty repository that will then hold your new Bicep files. And then you can start to branch out your code. You can see it from the graphics here. So the main branch is, let's say, ready to release code. And of course, when you start a new repository, it's empty. And then you can start creating a so-called feature branch that is, let's say, kind of a copy of the main branch, where you then start developing or creating, authoring your code. And then whenever you commit something, this happens in the feature branch, up to the point where you want to merge your changes back to the main branch. So after you have tested all of your code changes, you want to bring them back to the main branch for final release to the production platform. And this is then done by using a merge, and you will have a so-called pull request that has a defined process how you actually can merge back your changes. Because of course, once you merge back something, you know that once the code is back in the main branch, this will be released to your production platform. So that means you want to be sure that the code has been verified, it has been maybe approved by someone, and that's what the pull request process actually defines. So how can code be merged back into the main branch? And now let's say you release this code to the platform, the application is now running, and then of course you go into the next iteration, maybe for fixing a bug. Then you create a new branch and start all over until you have tested your new code, your bug fix or your code extension, whatever it is, and then again, merge it back to the main branch. The branches that you created to develop your features, your bugs, etc., they will not be needed anymore after you merge them. So you can literally delete them afterwards. So this is code repository management. And now the question is, if I have my code under source control and versioning, how do I now release this code to the platform? How does that now work? How is it coming from the repository out to the platform. And for that, we use pipelines. So the pipeline is literally a structured process that describes how your code that lives in a repository is taken out from the repository, is prepared, and is finally released to the Azure platform. This process can be very simple, which could be as simple as, well, take the code and release it, done. So that's the easiest form of a release process. But of course, you could also add quality gates to that process, saying, well, I want to analyze, for instance, certain alerts or compliance situations on the platform before I release the code. Only if everything is okay, I want to release the code, and afterwards I want to recheck that again to see if I broke some of the compliance rules, for instance. Or you could, for instance, before you release the code, do another code quality check to see if the code has been developed based on best practices, right? And if that's not the case, you could stop the release process, saying, well, developer, you need to go back to your code, fix some things, and then again release the code. And then maybe that second time, the quality will be met, and then the code is released. Or you could, of course, also have multiple, let's say, different environments where you say, well, I want to first release the code into a Q&A environment, and then do certain checks. And only if all of these checks are successful, then I will release the same code in the same pipeline to the production environment. So this is what can be done by using pipelines. And in a perfect world, of course, that full process is automated. There's no manual steps needed. All the preparation, code quality checks, the quality gates can be automated if your environment and your process allows that, right? Now remember, when you go back to your code and update your code, so you go back to authoring mode and you extend your code somehow, then you will use the same repository, the code from the same repository and the same pipeline to release the same code again. And that means that your release process should be repeatable. So you should be able to always repeat the full process with the code source, and that should not somehow impact or harm your production environment. So keep that in mind when building your release pipelines. Good. Now, how are release pipelines developed? Actually, they should be written in code as well. I mean, Bicep is all about infrastructure as code, and pipelines themselves should also be written as code, so that they themselves are actually managed as code in a Git repository, for instance. So the pipelines themselves that contain multiple steps, multiple configuration steps, multiple stages, that they should also be part of a Git repository, so that you make changes, that you can see what changed on my pipeline, that you could also roll back in cases of whatever misconfigurations, etc. All right, now where are pipelines created or configured? Again, multiple platforms that allow this. For instance, you can have pipelines in Azure DevOps. If you're using GitHub, you could use GitHub Actions. Again, these are just two examples. All right, now we also talked about code quality. And the last thing we want to cover today before we go into the demo and see how this actually works is the Bicep Linter. And of course, when we author Bicep files, we want to make sure that they don't have any syntax errors, that they are developed based on best practices that Microsoft suggests, right? And this is exactly what Linter does. It analyzes our syntax, our code, during the time when we actually develop it, and gives us certain hints saying, well, this should be changed because you're not following best practices. Right? Now, the good thing is, if you're using VS Code with the Bicep extension, the Bicep CLI, Linter is automatically integrated and you don't have to do anything. So all those best practices are already used. They are available for you automatically. You don't need to touch it. But what you can do, you can override the linter configuration by creating your own, let's say, linter config or behavior of linter. So for instance, you could disable it totally, which, well, I don't know, but doesn't make too much sense, obviously. So you should actually use linter. But you could, for instance, disable some of the rules that are used to check your code. So you can see on the right-hand side, that's just some of the rules that are available. So for instance, the last one, no unused vars. So that means you should not have any variables that are declared but not really used in your code, because then why would you declare it? And you can see if some of these variables are detected that are never used, linter will throw a warning. Now, let's say you're not happy with that default situation, then you could override the default linter configuration by creating your own linter config file, which needs to be named bicepconfig.json and needs to be placed either in the directory where your bicep file is stored or somewhere up higher in the directory structure. If you would have multiple bicep config files, it will always take the one that is closest to your code, right? And then you could say, all right, no unused vars, this check, this rule, I don't want that. I completely want to disable this rule. Then you could do that. And that means in the future, if you have unused variables, you will not get any warnings anymore. You need to think about yourself or for yourself, what makes sense for your specific code. All right. So 3 things covered: repository, pipelines, and linter. And now we want to see that in action. So Martin, would you take over?
Yeah, I'm here.
Hopefully.
Okay, let's see what I can share. Let's do desktop. So if we follow Martel's slide deck, then each and every one of the live streams that we have had during the last weeks, they are all the demos that we created are in this repository. So all the code is stored here, and this is a GitHub repository. So each time I'm doing changes or for each live stream that we have had, I have added new demos and merged the file through what Martel said, a pull request from let's say a feature branch. You can see that I already have this feature bicep series that I haven't deleted yet, but that could, since this is our latest stream, that I can actually delete this this branch. So now I have my code in a repository, and then I can, of course, deploy it from this repository instead of using my computer that we have done for the last few weeks. Now I can create a pipeline, but in this example, I'm going to use GitHub Actions and workflows. This is the same. It's a pipeline. It's just a different name for the same thing that we have that we are known for a long time now. So once we have this in our GitHub repository, then we need to configure the pipelines or the pipeline, depending on how many you need. There are some technicalities that you need to know. So you need to, in order for the servers that are running in the background deploying your code, you need some identity in Azure. So you need to connect to Azure. And to do that, in this README files, I have included all the details that you need and the links for the official documentation. But in essence, that what you need is basically an app registration in your Azure AD. So you need a service principal, an identity to connect to Azure, and then you need to give the permission to your subscription or your resource group. That's basically it. And then the next thing you need to do is to follow the exact demo that I'm showing a little bit later. You need to create secrets in your repository. So inside the repository, you go to secrets, and then you create these secrets. And the main here is the Azure credential. That will include the actual service principal ID and the secret or the password for that service principal. Then you reference these secrets as variables inside your pipeline. We can take a look at that. So I have created two examples. The one is this one here is called pipeline.yaml, and pipelines or workflows in both GitHub and Azure DevOps can be authored using YAML language. And what you also need to do then, since this is YAML, is try to follow this in indent here. So you need to have some kind of extension that you can see that your indentation is. So the first thing that this pipeline does is it does a checkout. So it gets the data we have inside our repository. And then the next thing it does is that it's logging into Azure. Everything here is documented by Microsoft. So what type of action that you're using and so on, you can find that pretty easily, and it's also included in our README file. Then you can see here that it's referencing the Azure credential. That's the secret that was created inside the repository. That includes the information that this workflow or pipeline needs to connect to my Azure environment or my tenant. And it's basically one more action, deploy bicep file. And here you can see that I am referencing the bicep file itself. And then for those of you who have followed our entire series, I am deploying the same SQL server that we have worked with in previous demos, and that needs credentials set for Azure AD for the SQL login. And then I also included that as secrets that you can define in GitHub secrets. So if we go back now to GitHub, then you can see that I have actually worked on these demos. So everyone who at some point tells you they got their workflow or pipeline to work on the first attempt, they are basically lying. That's not. I have never seen anyone getting their pipeline up and running on the first try. But this time it worked 2 days ago. So we can try to run this again. We go workflow dispatch is something that you can set for deploying manually. If this would have been a production environment, then you can set on for example, on each pull request to main or your whatever master or main, whatever you call your kind of default branch, then you can automatically trigger this pipeline. So this one is set up manually, so then I need to run my workflow from my main branch. So in a few seconds, this could start. Here we are. So this one, like I just showed, it just has basically two steps. It logs in and then it deploys. It already logged in and now it's starting to deploy the file. So if you go into my Azure environment, and then you can see that deployment main is currently deploying. Go into that, you can see it created a resource group, and then it calls this SQL module. And the file it's using is basically main.bicep. And then it creates the resource group, and then it calls what we have authored for last year. So it first creates a resource group, and then it uses the module inside the folder that we created for from our last stream. That's where well it work. And what we also want to cover is this linter specification that we have. So each time you write something or author your templates, you will have this best practices analysis going on. So if you have a typo or something inside your file, or you declare something that it's like we had this variable test, then that this is not the variable test is declared but never used. So that's the linter specification telling us we are not following best practices. But we can also alter this configuration, like myself said. So we have the possibility to change this through the bicep config.json file. Here you can see that for my demo purposes, I have set no unused params to off. So that means linter will say that I can declare how many parameters I want and never use them. I don't know why I should do that, but it basically shows it works as a demo purpose. So if I change this to error, then linter will then again do the same as it did for the variables. It will say you have a parameter that is declared but never used. Now this is finished. Confirm. Then to try out having some additional validation of our infrastructure as code, then I created another pipeline. And now I'm using the linter specification to check if our code is following best practices. Because you can very well, even though linter says that, hey, you have a parameter that is never used, then it's fully, you can at least commit it to your repository, and then possibly deploy something that is not the best practices way to do it. At some point, I'm hoping that Microsoft will allow us to write custom checks into this to the linter specification, but I haven't seen anything on the roadmap for that just yet. But I'm fingers crossed for that will happen. So what I'm doing now is that I'm adding basically one more step to our pipeline. Then I'm trying to build this file using AC Bicep build and our main module, or main file, basically. And if linter says this cannot be built because you're not following best practices, then this pipeline should basically stop and output the error message from the Bicep CLI itself. I can try that because I already have something in my main file. I think that will not work, or I can create one. Well, here it is. You see that I already deployed this file with this parameter that's never been used. So who, or the parameter name with the value of who, that's never declared. But since I have set this to off in my specification, so then it won't go in. Instead, then I reopen this file. Linter is now saying, hey, this parameter is not used. But I'm still able to commit this code. So if I was using another, or a developer was using something else, like let's say he altered his templates using Notepad, then he wouldn't have this check for best practices. So if I do a commit directly to main branch, of course, like every sane developer will do, without any good commit message, then we have let's call it an error inside our code. And then I can go to my actions again, and I can run this other pipeline that I have, so the Bicep demo linter. Now, if I run this from the main branch that I just committed directly to, then after a few seconds, if it tries to build this, you see it has a verified Bicep code step here. Now it will fail because we're not following best practice with this parameter file, or this unused parameter. Now it's validating the Bicep files using linter. Let's give it a few seconds. There you see. So no unused parameters. The parameter name is declared but never used. And nothing got deployed to our Azure environment. I then go back and change this, removing this one. Give it, add another good description for my commit. Go back to my action, See that it failed. Try to use my Linter demo again. Run workflow. And it runs the same step. It's the same pipeline. I never changed the pipeline. I just changed the code to follow Microsoft best practices. Now this validates that here it will go through, and then it will continue basically with the same actions that we had in our first example pipeline. So script runs successfully, and then it starts a new job, deploy the infrastructure. Of course, we have to wait for the cloud to find a host to run this on. Well, let's not use too much time waiting for GitHub to find a workflow. We can go back and check if it has deployed. But you get I guess you get the point of having the infrastructure as code and also have our pipeline defined as code, and then kind of use all the bells and whistles that we have available to us in order to have a good code base and also have a known configuration of all our infrastructure at the same time. Now we got this worker available, and I will continue to deploy the file. Any questions, Marcel?
No, not so far. Everything seems to be crystal clear.
Good. Anything I forgot to mention here now?
Don't think so. No, that was a great demo. Thanks for that.
Okay.
Unfortunately, it was the last demo, not only of today, but of our series, because the series unfortunately ends now. We're kind of out of content, but to ensure that well, you don't get too bored in the next weeks, we have added some links for you. So some useful links you should definitely check out before you leave, so that you have some additional fun with Bicep in the next days and weeks. Check out all our recordings. Again, the last recording will be published very soon using the first link. Then, if you want to check out Martin's code and again work through the different demos that he has shown, well, you can access his Git repository from GitHub, download it from there, and well, put your hands on that code yourself. Then there's also a nice Microsoft Learn series where you can also learn a little bit about Bicep, so you should also check that out. And then finally, there's the official Microsoft Bicep repository that you can access, because this is open sourced. And I quickly want to show you one thing that Martin showed me today. Oh, not that one. Second. Yeah, there we go. So this is the repository. I'll just open it like that so you can see, you can still see the link, right? And from here, you have this view on the different projects. And if you remember our last sessions, we always talked about Bicep version 0.4. But now in the make is 0.5, and if you go in there, you can see the planning elements, so all the stories, the bugs, and everything. And you can also track a little bit where Microsoft stands developing this. You can get some early insights into like bugs that will be fixed. You can get insights into new features that will be released. So definitely also have a look at that to get informed and to stay informed what happens in the Bicep world. All right, and yeah, sad enough, but that was it. I think I can speak for both of us that we had lots of fun preparing this and also delivering this. But everything comes to an end. That is today. So thanks for joining us during our series. If you still have any questions, feel free to ask. We will still be around for some minutes. If not, again, thanks for joining us during the series. All the best and see you soon. Watch out for maybe new announcements of other topics that we will release. We don't have any specific plans yet, but you never know. So stay tuned. Thanks a lot and see you soon. Bye-bye.